Okay, so we are going to look at 4 different types of information that we could get and have to find the equation of a parabola. The first is if we're given the vertex and the directrix. So our vertex is 1, -1, and then our directrix is the equation x equals -3. Okay, so with the vertex, we can already fill in a lot of our equation. Remember the standard form x minus h squared equals 4p y minus k, or it's going to be y minus k squared equals 4p x minus h. One of those two. This is if it's vertical. This is if it's horizontal. Right? Okay. So how do we know if it's vertical or horizontal with this given information? What, Coulton? The directrix is an equation that is x equals. And if you look on the horizontal column of your notes, the directrix is x equals h minus p. So this is a horizontal. So we need to fill into that equation. So we can go ahead right now and we can write, we know k and we know h, don't we? They gave it to us. So our equation so far will be y minus a -1, which would be +1, right, squared equals 4p times x minus 1. Or another way to look at it, it's always the opposite of what's in parentheses. So we have that much. We just need to figure out what the value of p is. So the only other information we have to go off of is that our directrix is x equals -3. So what's the formula for the directrix of a horizontal line? X equals h minus p. So the directrix equals a -3. So that can go right here, and for that, do we know the value of h? We do. What is it? 1. So we're going to rewrite this equation. The directrix is a -3, so x equals a -3. So we're going to write -3 equals h, which is 1, minus p. And then we have enough information to solve for p, correct? Subtract 1, we get a -4, and then divide by a -1 so that p equals 4. So now we're going to take that value and put it in right there, and we will have our equation. So we'll rewrite this as y plus 1 squared equals 4 times 4 is 16. X minus 1, you have just discovered the equation of the parabola with that vertex and that directrix. Just looking at the vertex, we can't decide if that's a horizontal or vertical. We have to look at the focus. And what's the focus for a vertical is h, comma, k plus p. The focus for a horizontal is h plus p, k. So on the vertical, the focus, the x-coordinate doesn't change from our vertex. So is the x-coordinate changed from our vertex on this? So that means this is a vertical graph. And we're going to be plugging into x minus h squared equals 4p y minus k. And we know 2 of those values already, right? We know h and k, so let's go ahead and plug those in. X plus 2 squared equals 4p y minus 2. All right, so now we need to figure out what the value of P is. So on a vertical, the focus is H and then K plus P. Right? All right. So we know H is -2. That's not going to help us find K or P. This is what is going to help us find the value of P. So that equals 0, correct? So we're going to say that 0 equals K plus P. Do we know the value of K? It is 2. So we can plug that in because K is right here, right? So what is P's value then? -2. Now we're ready to rewrite our equation. Four times a -2 would be a -8. Y minus 2. So we've gone through two types of problems. Each one we were given the vertex. One we were given the directrix equation. This one we were given the focus point and able to find that. The next two problems we will not have the vertex. So there'll be a little more work or different kind of work involved. Are you ready? Focus, we really can't tell whether it's vertical or horizontal. We're going to look at the directrix. And the horizontal graph has a directrix that is x equals something. So we know that this is horizontal. And that means we're plugging into this, y minus k squared equals 4p x minus h. Okay, so now we're going to use what we know about the focus and the directrix of a horizontal. So what's the focus formula, Cheyenne? What's the focus for a horizontal? What is that? And then K. All right, how about directrix? Kenny, what's the directrix equation? H minus P. Okay. So we have two things that involve H and P, and we're trying to find the value of P, correct? Or actually, we're trying to find H and K as well. K is right here in our focus, right? So K is a -1. So let's go ahead. We're going to say K equals -1. We need to find H and P still.
Wouldn't H just be halfway in between what x equals and the value of x on the focus?
It will be, yes. So looking at the graph, there's two ways to approach this. We can do the algebraic way. We can also look at the graph. So in what Logan was saying, so our focus is at -1, -1, right? And then our directrix is at x equals 5. So there's our directrix. Remember, our vertex is halfway in between those two because it's equidistant from the directrix and the focus. So halfway in between would be at 2. 2, -1. Okay, so H is 2. That's how you could graphically find that. Let's look at how we could algebraically find it. What we're going to do is we're going to use the fact that for the directrix, x equals H minus P. So there's our x value. So 5 equals H minus P. And then for our focus is H plus P. And that value is -1, right? So we're going to say -1 equals H plus P. And some algebra review. That's a system that we have. So if we added these two equations, the p's would cancel. H plus H is 2H. 5 minus 1 is 4. H is 2, which is what we got right here. And since we know h is 2, we could come up into either one of these equations and plug in 2 and find the other. So where we have x equals h minus p, that was this right here, the 5 equals h minus p. If h is 2, we could say 5 equals 2 minus p, and then find the value of p, which will be -3, right? So we get 3 equals -p, so p equals -3, and we're ready to plug into our equation. And that's going to be y minus k, which we said was 1, equals 4p, and p is a -3, so that's -12, x minus h, which is 2. So, if you want to do the graphically, that's fine. I'm fine with that. You'll have to take that value then to plug it into one of these two things to find either this one or your directrix to find what the value of p is. Yes, Ethan. Yes, because that's 1. Yep. K is -1 up here. Yeah, good call, good catch. Because our focus is h plus pk, and so k is -1. I didn't bring that negative down, which will change this equation. Anything else? Everything else okay for k? All right, let's go on to the next one. So from the focus, we can identify one part of our vertex for sure, right? So it's going to be 3, because the focus is 3, 2. The focus is h, k plus p. So our h is 3. And then you could graph to find k. I'm going to just use my 2 equations here. So I know from my focus that k plus p is 2. So I'm going to write k plus p equals 2. And I know from my directrix that k minus p equals 0. So I'm going to write k minus p equals 0. Solving the system, if I just add my variables, k plus k would be 2k. P minus p would be 0, so I get 2k equals 2. K equals 1. So I have h, I have k, and now I need to find p. So I'm just going to go back into this equation and substitute what I know in for k. K is 1. So 1 plus p equals 2. What does p have to be? So p is 1. And now you can plug into the equation. I'm going to have to, let's do that right here, I guess. So my final equation would be x minus h, we said h was 3, equals 4 times p, and p is 1, so that's just going to be 4. Y minus k, and k is 1. All right, so I'm going to give you 4 problems, one like each of the 4 that we did as your assignment to try it to work over the weekend. We will have class Monday, barring any other issues, and we'll go over this and figure out any issues that we need to do. Okay, so your assignment's going to be from the book.